Hello and welcome to TidyX episode 27. Hey, friend! Alright. So, TidyX is a screencast where we go through and try to explain how our code works and explain our concepts. My name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And I'm Patrick Ward, and you can find me on Twitter at OSPPatrick. You can find both of us on Twitter at tidy_explained. And you can reach both of us, should you choose to, via email at tidy.explained@gmail.com.
Yes, alright. So,
Here we go.
hey, friend.
Tidy Explained 27.
Yeah.
One of my favorite TV shows.
Yes. So this week's Tidy Tuesday data set is from Friends. It's the I believe it's the scripts from Friends. It was created by Emil. So this was a great fun data set. I think a lot of people put together some interesting visualizations. Obviously, using playing on the theme, on the colors, like all the different characters there. Admittedly, I never really watched Friends. I think I was right in the middle of the generational. I don't know, or I just didn't watch much TV. I know a lot of people in my generation that I don't know. But Patrick, you liked it.
I've seen every episode. Friends and Seinfeld were they were a big part of my college days.
Gotcha.
Every night, that's what we watched. Yeah.
There you go. All right.
Yeah.
So like I said, some great submissions, but one that we thought people would find interesting was from my friend Leon. So he created this fun visualization here where he's asking the question, who uses the most fancy words? And so he took the transcripts, or the scripts, I guess, not transcripts because they were pre-written, and went and calculated what the LIX score is, LIX. So that is the complexity of the words per sentence, basically, of what each what each character said. And so you go through, you can see Chandler, the first two seasons, you peak out at 21. Complexity there, complexity of read lines. He's very complicated at the beginning. Towards the middle there, everyone's kind of dropped in their LIX score a little bit, and then towards the end there, Chandler jumps back up again. And Joey, strangely is relatively high compared to everyone else. Middle of the ground at the beginning. I know that he's the character that everyone kind of bags on. So
Yeah, he's kind of like the doty, the dumb one, rather. Yeah.
So
he's kind of like the guy that they all make fun of. The interesting one is Ross, I guess, because he's the PhD, like the archaeologist type of scientist guy. And so you'd think that maybe, although Phoebe, she's kind of like the bubbly, airheady one, but
hey,
yeah, it's interesting.
Yeah, well, we thought it was a lot of fun, so I reached out to Leon. I was like, "Hey, Leon, you mind sharing the code with us so we can try to explain it to all our viewers?" He's like, "Yeah, sure, totally." So he actually sent it to me in an email, and he did a really nice thing. He actually made it into an R project for us, which I will bring up here. So what that means is that he used this R project here, which you can create using this button right here. Let me zoom in a little bit. This button right here, which means that now your working directory is set to here, so that you can use packages like here to reference your data paths. It makes it a lot easier and a lot more transferable for everybody. So if you're not using our projects for things you're working on for your projects, definitely do this. And also, he organized it really nicely. So he's got his R code in this R folder here. He's got the data from this Tidy Tuesday in the data folder. Images that he uses in the images folder here. So it's really well laid out. I didn't have any confusion taking a look at this, where everything lived. So thank you for organizing it like that.
Awesome.
All right, so now we're going to hop into his code. So first thing Leon does is an rm list equals ls, which is controversial because this actually does not clear out your entire workspace. What this does is it deletes all objects that might be inside of your environment. So Jenny Bryan is quoted saying, if she sees this, she'll burn down your computer. So if you don't want Jenny to do that. But this, I know I've done this in the past. It's useful for when you don't want to clear out your libraries. You don't want to start a new R session. but you want to delete everything that exists in your environment, which is what this is doing. So keep that in mind. If you see this, this is not clearing out everything. This is just deleting all the objects that you see in your environment panel right here. So I think that's a critical thing that a lot of people should know. Next, we hop into loading libraries. He's loading Tidyverse, which we all know and love for data processing, cowplot, which we've used in the past for doing some image manipulations to ggplot, and then loading the library magic, which is also for image manipulation, which is, it does some cool stuff there. Patrick, do you maybe want to explain the next couple lines here?
Yeah, so on top of loading the packages that he planned to use, he also created a few functions up front, which we've talked about before. We like to also load our functions at the top with our packages. So his first function is, as the name implies, he's going to get the data himself rather than using the TidyTuesdayR package, or rather than using the slug that's provided on the GitHub page for Tidy Tuesday. So he's just got a quick function there that will take the URL and the data set that he's interested in pulling from, which has the transcripts of the show notes, or show lines rather, and then he just reads the URL and the data set in using read CSV, as we've done before, and then he writes it to a TSV file, and that's how he's going to load it in later on down the line. Mm-hmm. And then he's got another function here. This is the count long words function. So this is a function where it takes in X, some string or bit of information, and it takes in this argument that he calls len underscore long, which is basically you get to specify what you want a long word to be. So if a long word to you is 8, you'd specify len long to be 8. So it's whatever you'd want it to be. And he starts out by taking the X variable from that argument and splits it on the words. So he's creating a string split. He's creating a string of all the words within that sentence. Then he counts up the number of characters within that sentence, so the characters within that X split. So that's what the nchar function is doing within lapply. So that's a list apply function. It's taking the X split variable that he created above, and it's passing the nchar function across that X split and putting it into a list. And then he finishes with this n long words object that he creates. So now he's using sapply, which is similar to lapply. These are from the base apply family of functions if you're trying to pass a function over something. So over the X split number of characters variable that he created, he's now passing this little function here, which is basically just evaluating the characters, and it's saying is the sum of the characters greater or equal to len long, which remember is the number of specified letters in the word that you pre-specify. If it's greater than that, or equal to or greater than that, you're going to call it a long word, and then you're returning the long words. So that's what the count long words function is doing. Mm-hmm. And then the next one is where we get into this this LIX definition, which is I had never heard of, which is super interesting. It's basically a way of evaluating the difficultness of the words based on based on what's in the equation here in the getLIX function. So
yeah, exactly.
Yeah. And so it's like an arbitrary value, but you'll see here how it works. So here's his function. He starts out with this string count. So it's counting the words. So this is a bunch of regex expressions. If you do enough of this stuff, you have like a love-hate relationship with regex expressions. I tend to be pretty sloppy at them, but he's counting up the words there first. Then he's counting up, it looks like punctuation, right?
So yeah, he's counting figuring out the number of words that exist in X, then figuring out the number of sentences that exist.
Sentences based on the punctuation. So a period, an exclamation point, or a question mark within the brackets there. Yep. Then he's counting up the long words. So he's counting up using that count long words function. And then this is where he calculates the LIX score. So it's going to be the number of words, the words divided by the sentences, added to the number of long words multiplied by 100 divided by the sentences.
Number of words.
Oh, the number of words. Sorry, not the sentences.
Yeah, it's a it confused me. Like it's because of the way it's written too. You've got to remember like order of operations of everything. And what's going on with that? But suffice it to say, it's calculating LIX.
Exactly, it's calculating LIX.
Yes, and then going to return that for each, and then it's going to return that value.
And then, exactly. And then that'll give you that score that he's kind of got the magnitude of the score written there. So we'll see what that means.
Yeah. So basically, if it's greater than 50, if LIX is greater than 55, very complicated, like an academic literature, it'd be really complicated to read. Conversely, lower or equal to 24, it's really easy reading. Children's literature, something like that. And then there's obviously middle ground between there. So yeah, it's just like a way to try to quantify how complicated the text is that you're reading. Cool.
That's interesting. Never heard of it.
Yeah, I hadn't heard of it. I'd heard of it before, like kind of in passing, but I'd never actually seen it done.
Yeah.
So, all right. So it helps if I load the libraries and don't just talk about them. All right. So first thing Leon does is he loads in the data app. He's downloaded it with this function here. He's downloaded it once, so he's not going to do it again. So he's going to load the data set here. We've got friends data. Here he's got text, speaker, season. And so next he goes through and goes, well, who are the friends that are in France? And it's Rachel, Ross, Chandler, Monica, Joey, and Phoebe. So these are the characters we really care about, because obviously there's other ones, or there's like scene directors, stuff like that this is for the script. This is a script, so it's got a bunch of additional stuff in there that we don't really care about. So let's forget about that. So then he takes the friends data, so this data set here, filters to keep only those friends, and then starts doing a whole fun set of rejects for us again. So I'll take a stab at explaining this. So he takes speaker and does a str split on a space. So what he's going to do, like these are the values that are in speaker essentially. And str split will split this and turn it into a list that has, helps if I type. The first entry has the values Rachel and green. This is how it split it up. And then the next entry would be Ross Geller. All right, so as you can see, it's removed that space because it's split on them and put the two words in two separate locations there. So then what he's going to do is use map and grab the first value out of that. So mapping on this would grab Rachel and it would grab Ross. But because you used a map, it's still a list. So unlist will unlist it. What? It's like the name does what it says it does. So then you end up with a vector of their first names. So it's Rachel, Ross, Chandler, Monica, or Joey, or Phoebe. Those are the only values now. Next he goes through and does some regular expressions on the actual text itself so that you can actually calculate the LIX score. He does an str replaced. So the way I'm reading this is he looks for a dash, a comma, a semicolon, and replaces it with a dot or a period. So he's now gone through, identified all those, which I guess could be like you can think of them as essentially different sentences. They might be combined with these parts of, not parts of speech, but the English language punctuation.
It's
like
not
separating
really,
ideas.
Yeah, they're not really. They're reading a script. It's like this is conversational writing. It's not like
Yeah, like as we're doing.
it's not the same, right?
Yeah.
Yeah, it's not the same thing.
Yeah, exactly. So then he goes through. It's like, all right, now he's replaced all those with periods. Now he's going to go through and do an str detect, or a case when, as we like to talk about, where first look at each of these strings here and try to identify, is there a period, exclamation point, or question mark at the end of that sentence, or at the end of the text there. If it is, return it. Cool. It's exactly how we expect it to be. However, if it isn't, so this is kind of like flipping your logic a little bit, but so in all the cases that doesn't happen, now attach a period at the end of it. So even though we do true tilde, so you want to automatically think, oh, well, when it's true, it's like the opposite of this. Yeah. Or like when this doesn't happen, now do this. So now he's going to look for all the cases where the text doesn't end in a period and add that period in. And then finally what he does, he goes through and replaces the punctuations. So the exclamation or the question mark replaces it with a period also, because LIX score does not care about the punctuation that's involved with it. All it cares about is what is a sentence. Yeah. How do you define a sentence? And so that is what's going on with this. He's removing all those extra punctuations and change it into a period there. So now we've got friends data clean, where every sentence here or every entry here will end in a period, and any other dash or semicolon will now be replaced with a period as well. So now is going to go through and actually calculate the LIX score. So this is a thing that we've done several times now, where he takes this data set, does a group by speaker and season. So for season 1, speaker Chandler, summarize. So for all those values, concatenate them with a space. Mm-hmm. So that's why he added that period at the very end there, because he wanted to make sure that he could then separate on that in the future. And then do an ungroup. So now we've removed this grouping that existed here, and then calculate the LIX score for across for each speaker and for each season. So we've done that and calculated that. So now we'll end up with a data set that is the speaker, the season, and what their LIX score is for that season, and then all the lines that they spoke that season. So I'd imagine they can be pretty long there.
Yeah, it's got to be massive.
All right, so now he's got his data all prepped and ready. Now it's time for the actual visualization. And he did a cool thing that we've seen a couple people kind of do, and we always like to highlight this, is he went through and predefined how he wants the various pieces to look. So he set his X label to be season, Y label to be complexity, of read lines, parentheses LIX, title, subtitle. So he's just predefining all those things for us. So he doesn't have to remember to go into his actual ggplot to update it. He can just update it here, rerun it all, and it'll come out exactly as expected. So it's just a little bit easier to update that stuff there. Setting friends call, so he's defining the colors. I'm assuming those are the colors that were found with friends. It's a bunch of hex codes that are hard for me to read all the time. You immediately don't know what they are unless you're incredibly smart. And then plot file, so this is defining where he's going to be outputting it. 2, defining the plot width and height and DPI. So let's all run that, and now we get into something we're very familiar with, which is the actual plotting. Patrick, you want to take us through this?
Yeah, so this is just our standard ggplot fare, really. So he's going to assign the plot to an actual name. He's going to use the friends data that he had just created with the LIX score. In the ggplot, he's got his X variable. He's going to have season, and on the Y variable, the LIX score, colored by speaker and label speaker. So he's going to want to, if you remember what the plot looked like, there was a label at the start and at the end of it that had the speaker's name. So the geom text is what's going to get labeled here. So the data is the friends data. The seasons are 1 through 10. And he's going to use these little nudge functions or nudge arguments within that geom text function. And that's just going to nudge the speaker name a little bit up and down on the X and Y axis so that they're not like overlaying the line or something like that. Then he creates his line. Obviously, he's got a line width, so he wants it a little thicker than the standard. And then the alpha, as we've talked about before, gives it some opaqueness. He's got his scale set, so he wants very specific X continuous scales to be a sequence from 1 to 10, obviously because there's 10 seasons in his data. He sets his colors to be the values that he pre-specified with those hex codes above. The theme is going to be minimal, and then he's going to basically layer in his own theme over top of that. So he's got his plot background. He doesn't want a legend. He's got his plot background. He's going to make it all black. He's got information about the plot title, which he's already named up above. He's got all of this all of this stuff is basically the styling that we've done a million times. How big you want the subtitle and the caption to be, the plot margins, the panel grids are all about the lines that we see on the X and Y axis. So he makes the minor grids blank. The major grids are going to be gray, so they're going to stand out a little bit on that black backdrop. He's got the panel grid major X is going to be blank, so there's going to be less or no X major grid going across horizontally across the plot. Information about the axis text, so text and title, so how big he wants those to be, the colors, which again he pre-specified. So all of that stuff was done ahead of time, so he could basically just plug in exactly what he wanted, and then hit obviously his labels. And when you run it all,
uno momento,
you're going to get a nice looking plot that looks like this.
Of course, here let me zoom out so that it renders. I think I figured out that's why it doesn't show up nicely in my views, because I zoom in so everyone can see the code. So there you go.
So there you go, and you can see how the nudge of the names just moved them slightly off of the, basically off of the lines. If you didn't do that, it would basically put them right, right at the end or the start or the end of those lines.
Yeah, and it would just overlap it and just not look very good.
Yeah, exactly. Yeah.
So this is just separating it out.
Yeah, and you can see that the X major grids are gone, so there's none of the Y major lines are there. They're gray. There's no vertical bars at each 1 through 10 season number, right? And so that makes it. We've done that a bunch, and that makes it look really nice as well.
Exactly.
And then he does some stuff with saving the plot. If you were to save it, which he saves into his, I think he saved it into the R project as well.
He did, but before he finished it off, what he did is used cowplots.
Oh yeah, this is cool.
So he could add an image to it. So we've covered this very briefly before, but you use ggdraw. So this is going to set up a blank canvas for you. Then you say, so now it's just a matter of ordering things, like which order do you want things to appear. So first draws the plot. So this is the main plot that we just created, that we just talked about. And then he adds this draw image, which is from cowplot, which now it's going to draw this image that he has inside of the R project, which is why it's nice to be using these R projects, because now I didn't have to edit any of his code. It just had the correct path set up for me. He's setting the scale, which is the size of the image, the H-align and V-align, which is the vertical and horizontal alignment of that image within the ggdraw that you've got there. So now we'll run that, and then we'll replot that. And what we've got is, in this lower right-hand corner here, he put in the Friends logo and the actor photo. Don't know what that would be called normally. The logo? Huh?
The
promo.
Promo, sure.
The promo shot.
Yeah.
That he's got going on there. So that's fun, and so now it kind of adds a little bit of fun there to his. Let's let it re-render. Oh, did I zoom out too much? All right, but yeah, so now we've got that there, and got the friends there, and it's just fun. I like
Yeah,
that. And then
awesome.
he uses ggSave to save it, setting the height, width, and DPI, and setting it to be file or plot name, which is a specific location inside of the R project.
Yep.
So, yeah, thank you so much, Leon, for letting us go through this. He's got lots of great code. You should definitely follow him on Twitter. And he's just a really smart, awesome guy. All right, so now we're going to hop back. So now it's episode 3
Yes.
of the Shiny series. So we are going to hop over there and start doing that now. All right, give it a sec. Because we're using projects, I'm able to just immediately jump between them, and it's not a big deal. All right, so now we've got Shiny NBA app part 2, overall of our series, part 3. So we're picking up from where we left off last time. So we're not going to touch on this previous stuff. If you want to learn more about this, go and watch episode 26, where we go through and explain in depth this beginning stuff here. But this is just loading in a bunch of the libraries, tidyverse, shiny, patchwork, loading in the data and doing some filtering and whatnot. We've got going on there. Now I took all the code from last week, and because we're going to be explaining some new concepts there, I didn't want it to be cluttering up the page here, so I put that inside of a helper funcs.r script, which we source in so that we can use what we created, all the functions that we created in there. But we're not gonna go through and explain those. They're identical to what we did last week. But now we're gonna hop into the UI, which is different from last week now.
And the goal, so to revisit, the goal was, or the inspiration was, we were looking at the Carmelo page from 538, which if you ever want to see like really nice visuals of things, either sports or politics or world events, I think 538 does a wonderful job just showing data. But this was the inspiration, and we could build this as a Shiny app on one single page, and that would be kind of cool. But I think, we really wanted to take this series and show some of the diversity of Shiny. So the stuff on the left side of that page is what we focused on last week, right? Creating the grids and creating some of the information about the player's performance within a given year. This week, we're going to do something that's similar to their little box there, which is showing wins above replacement. We're going to use the basketball reference stat value over replacement because it was conveniently in the data set. And rather than putting everything on one single plot, we're going to show you how to create tab sets within Shiny. So basically, tabs that contain different bits of information. And the reason that we're going to do this is tab 1, is going to be from last week, which is just showing you the player and showing those grids on the left side of the Carmelo page. Tab 2, we're going to show some value over replacement over time, but allow you the opportunity to select multiple players. So if you were using this to compare players, set your daily fantasy lineup or whatever it is, you could build something like this that allows you to look at different players.
Exactly. All right. So what we got going on here, I can speak English. What we've got going on here, fluid page, same as we had before. Title, I added that in because it's 2017 NBA player statistics. We've got the sidebar panel, which is the same as before. We're allowing, it's a width of 3, so it's only 3/12 of the width of the page. I updated it to use select eyes input. It was select input, but they functionally are the same, where we've got an input ID, which will then be used in the server when we're trying to access.
Do you know the difference between select eyes and select input?
It's the JavaScript library that's kind of running in the background on how it behaves. So select eyes input allows you to type into it. Select input, I prefer select eyes, and also select eyes you can create more complicated. So say choices were NBA player, we have that here, but we wanted to add some context around it, like what team they were with, and put that in parentheses and stuff like that, or have an image to go along with them. We can do that with select eyes input. You can't do that with select input, as far as I know and understand. It's been a while since I've read the documentation, but I believe that's the difference.
Okay. Cool.
But yeah, so they've got the label there, which is like the text that shows up above it. We're allowing them to select any NBA player that we've got stats for. By default, LeBron James, because Cleveland. And then multiple is false. That means that they are not allowed to select multiple players in this selector. Next, we hop over into our main panel, and this is where the magic is happening. This is where the cool stuff. So the first thing we've got here is a UI output. And so as you see in the Carmelo app here, it's got this little summary of the player here. So like name, where they play, what their position is, how old they are, and a photo of who they are. So we're going to be creating that as well with Shiny. But we're going to do that with a UI output. So UI output means it's similar to the plot output and table outputs that we've talked about in the past, but this time we're actually outputting HTML for it to render for us. So that's what's going on there. We'll touch on that in a sec. But the key thing that we wanted to talk about this week was tabs. And so we're setting that up with tab set panel, which is telling Shiny, hey, we're going to be creating a bunch of tabs. Be on the lookout for this and treat them like tabs. So next we go in, we actually create the actual tabs with tab panel. They need to have a title. So we gave the first one player data. So that is the title of that tab there. And it contains the same information. Like this is the code that we used last week. The plot output, PLT score, and PLT def. That's what we had last week. So don't really need to cover that last week. But now we have the second part. So this is the second tab panel, which is the VORP. What is the VORP again?
Value replacement player.
All right. Yes, value over replacement. And so what we're going to do here is use column to say, hey, we're going to be filling up this whole width here. Have the width of 12. We're going to allow a selectize input. And this is going to be the players that we're going to be comparing against our original selected player here. They can select any player again. And we're going to be generating an output we're calling VORP.
The one thing about this that's tricky that you have to keep in mind if you're working in tab sets is the input ID here in the second tab. It can't be the same as the input ID in the first. So in the first tab, we had input ID as player. In the second, we have to change that to something else, like player VORP comparison. You could have changed it to _2. You could change it to whatever you want. And that's a little bit, like, for a while that messed me up because it's not super intuitive. I always thought input ID had to be the column from your data that you were pulling from, and that's not necessarily so. So just change it to something else. They just can't be the same, otherwise R is going to bark at you and throw up
All right, so now I've got that, and now we're going to hop into a server, which is where all the magic happens. All right, so we've got the same, this is the same code as last week. We're labeling that as tab 1. We're not going to discuss that, like I said. Watch last week's if you want to learn more about that. We're on to some fun new stuff, which is creating the interactive or the UI that's going to be updating whenever we update the player that we've selected. So first thing is I wrap it in an if input player is not equal to an empty string. So what this is going to do is going to protect it from actually executing unless we've actually selected a player. And this is just like you don't need to have this in there. This was because I didn't want it to be showing errors when we hadn't selected a player. There's no need to do this functionally.
Makes it nice though.
Yeah. Next we go through and we pull out from the vitals data set the player that we care about and then calculate their age because that wasn't included in the data set there. Next we'll so now we end up with a data frame that is one row and it has several different bits of information about the player, like what year they were born, what we were able to calculate their age, and some other statistics like that. I think that's the only one we end up using is age in this one.
Yeah, which is, and it's a weird, there's something wrong with the data that we had here, because it said I think in 2017, J.R. Smith was playing basketball at the age of like 77. So there's no way.
Seems reasonable. Old man running up the court. Then we have the stats data set, which is the original data set that we read in. We're going to be filtering to only keep that player. I have this ungroup here because I think it still had some grouping information left over. We're going to only keep year 2017, which is the year that we were looking at before in the prior table, so I wanted to make sure we were consistent with that. And we're only going to keep the columns positions. So what positions did they play over the 2017 season? What were the teams that they played for in the 2017 season, and how many games did they play in? Then we're going to do kind of a strange thing, but essentially what's happening here is we're going to split on a space, assuming that the spaces in the name indicate difference between first name and last name. And we're going to only keep this //w, so identify all the non-words and replace them with, just get rid of them. Because like I'll explain it in a second, but actually we didn't want to have like t.j, we wanted to have tj. If that makes sense. Because for this next piece here. So this is the HTML that we're going to be outputting. This is using Shiny's tags. So we're going to create a div element in HTML. We're going to give it some styling. So this is going to be a display flex with a padding of 10 pixels at the very bottom. We're going to create another div that is going to be essentially on the left-hand side, that is going to have a header of level 2 with the player's name, and then just some text about what teams they played on, what positions they played, how old they are, and how many games they played that year. They're all going to be in uppercase. So that's what the two upper is doing here. So now we've got a div on the left-hand side that has player, team, position. They're 28, and they played in 74 games. And then on the right-hand side, to match what was happening in the Carmelo app, we're putting an image of the player. I was lazy and didn't want to go through and actually try to figure out a good way to be pulling that out of ESPN or anything else, but somebody very kindly came up with a nice little app that allow you to do that, and all you have to do is go to their URL, but the way they set it up is they wanted it to be, so this is their app, nba-players.herokuapp.com. The full path that you need to pass to it is players/last name, which is why we split up here, and then first name. Or excuse me, players/last name/first name. So like for LeBron James, it'd be players/James/LeBron. And so this kind of nicely pulled it out for me, so I didn't have to go through and figure out a bunch of code to extract it for us. And then I'm setting the style so that image will be 180 pixels tall, and the width will be auto based on the actual size of the image that it pulled out. So that's some nice HTML that'll be generated whenever we update the player we're looking at. It'll update this information for us as well. So we'll suppress that, and now we'll hop over into tab 2. Patrick, do you want to start explaining tab 2 here?
Yeah, so this is where we're going to actually now work on building some of the plot for the VORP over their seasons. So the observe event is basically a way to update the selectized input information that the user is providing. Mm-hmm. So here we have an observe event function, and we pass it the input player. So whatever the user selects in that sidebar panel, that's going to be that player. And then we update the selected input. So we're basically going to update the selected input using the input ID player VORP comparison, which is for that second tab set. And we give it a label. So compare input player against ... And then the choices here is the kicker, right? And this is why we have the observe event and the update select as input. Is that right here, we're basically using this set diff function. And what that function is doing is it's taking a set of vectors and it's finding the difference. So here it's saying the unique, find the unique NBA stats players who are not the inputted player, right? So we've already selected that guy. He's been selected in the sidebar. His individual data is going to be in tab 1. And when we go to tab 2, we know that's the player of interest. So we only want players that are available that are not that player, right? We can select anybody else. So that's going to be the choices that we have to choose from. And then the selected here, we use the setDiff function again. And we say that we want the players that are left over or not that player in the player VORP comparison, which is where the people are going to be able to type in on that tab the players that they want to make a comparison to. And that's going to produce the line plots across their careers, which is where we'll get the data here in this reactive section. So we've created this, we're going to create this kind of reactive data frame called df tab 2. And within it, we're going to use the stats data that we imported. We're going to filter between the years 2000 and 2017. And we're looking for the players that are within the VORP input. And it's all, as well as the input player that's in the sidebar panel. So there's two inputs essentially that the user can interact with. And we want to make sure that all of those players that they select are indeed selected in the filter. Then we're going to group by player year, and then we'll summarize over the VORP. So this is for any of the players that kind of really low value players that might bounce around between 2 or 3 seasons. We'll give them credit for those. We ungroup to get rid of any of the grouping information that we did above, and then we just do this little this mutate here. So we turn the players into factors, and that's just going to make sure that they keep the levels or keep the ordering that they've been selected in. Okay, so that's how we'll get our data. And now we take that data and we're going to do our output. So we're going to output it to VORP, which is the plot that we did the plot output for. And we use the render plot function for that. And we take our df tab 2 data. Remember, because it's reactive data, you need the parentheses. So if you put it in without that, it's not going to work. So we take that data, and then now we're into straight ggplot2 land here. So we're going to ggplot2. We want year on the x-axis and the value over replacement player on the y. We want to make sure that we color this by the players selected because we'll have multiple players, so we want to differentiate them in some way. We have some information here about the point sizes, so we want them relatively large because it's a big page. The position here, I set this to do this little dodge thing. And the reason why I did this is similar to how Leon had the nudge. The dodge is just going to take our data and just slide it a little bit, and that'll prevent any overlapping that might occur. So if we were to select 2 players that are relatively similar in the way that their value over replacement progressed from 2000 to 2017, if they overlapped, it wouldn't give us any information. So the dodge just is going to say we're going to dodge by a width of 0.4. So it's just going to slide them a little bit. And because I did that to the points, I also have to make sure I do that to the lines. Otherwise, you'll have points that are moved and lines that don't follow. Yeah, it'll look really offset and weird. So line information, I make the lines a little bit bigger than normal. I choose dashed lines here so it doesn't look too busy. Again, I set the position dodge to be the same to the point. And then my Y limits, I just go anywhere from -4 to 14. I think if memory serves, I selected those values because I ran a quick quantile and found the min and the max. So that might have been the reason why I did that. I can't remember.
To make sure it was consistent so that when you updated the plot, the scaling didn't change. So you could consistently.
And that is a really good point. And I've run into that before, forgetting to set the Y limits in things like this. And then I've had people looking at data and saying like, wait a minute, why is everything always changing? Like this guy, this guy's not a good player, but So
it's filling up
setting
the plot. They're at the very top. They're at the very top, and they're not very good. Why is that?
They're at the very top of the bottom. You just can't see it because I haven't set the Y limit.
Yeah.
So that's the visual, and that's the entire server side of the Shiny app. So we can run that, and then we can run our Shiny app function, and we're gonna get a pretty cool.
Hey.
There we go. Best player in basketball.
LeBron. So as we said, so this is the player's name, team, position, how old they are, number of games they played in 2017, and that image from the Heroku app we pulled for them. There's a little bit of padding there, so it's not like right on it, as you can see. There's that little gap there. Now we've got the 2 tabs. So that was like the focus of this. So we've got player data, which is the exact same plots that we were showing you earlier, with the scoring and the defense. But now we've got the VORP career comparison tab too. So what's it going to look like?
Let's see. Boom. There's
hey,
LeBron.
There you go. So now we're going to compare LeBron James against, who do we want to compare against?
Well, first show, if you tried to compare LeBron to LeBron, it's not going to work because we've explicitly said that, see? So that's pretty cool, right?
Yes.
So let's compare him to an aging Dwayne Wade. There you go.
Womp,
So
womp.
he was definitely on the back end of a career there. I think I saw LaMarcus Aldridge in there. He probably was a kind of a rising star at this time, I'm sure. There he is.
Nope.
No, well, yeah. I think when we were looking at this, I think Seth Curry was like the closest to a value as LeBron. Yeah, there you go. So he was definitely a rising star at the time, right?
Boom, yeah. I mean, I remember 2014, 15, 16, 17.
Yeah. Splash Brothers, right?
Yep. You know,
That's
gotta
pretty
get Clay.
There he
Gotta
is.
get the other piece. Oh, he's down here.
He's still over 0 though, right? So,
exactly.
Better than.
Still valuable. But one thing too that we can bring up is we set it up so that if you update this will be updated if we selected a player that was in here as well, right? So it'll remove them. So like say I want to look at Steph Curry. It went through and it removed it because we can't compare Steph against Steph. So now it's updated that. It's updated the image here where he plays, position, how old he is, number of games he played, 79, 2017. But this plot more or less stayed the same. Let's add back LeBron. There you go. It's the same plot. It's just kind of reordered a little bit. And there you go.
Yeah.
That's a way.
So next week we'll add one more tab and we'll see how this thing looks.
Yeah. Well, I think we'll be pretty close to that Carmelo app and showing how you can recreate it all through Shiny.
Yeah.
So
awesome.
It's fun. It's cool. Hopefully y'all are enjoying this. Please let us know. Leave comments down below. Like the video. Tweet us. Share this with your friends and everybody you know, friends and family. You want like, hey, you need to learn R. You want to know why? Because you can create Carmelo app. You can recreate 538 stuff, on your own, so you're not beholden to them.
Exactly.
And have all that fun stuff. Sweet. Well, I guess we'll call it here. We got through everything.
Yep.
All right. Well, thank you all for listening. My name is Ellis Hughes. As always, you can find me on Twitter at Ellis_Hughes.
And I'm Patrick Ward. You can find me on Twitter at OSPPatrick. You can find both of us at Twitter at tidy_explain, or you can email us at tidy.explained@gmail.com, or you can comment on the videos if you have questions. Some people have done that. You can send us messages in Twitter if you want to do that. Either way, feedback, questions, always welcome, and we'll touch on some other things that people are interested in.
Yeah, for sure. Yeah, let us know. All right. Thank you, and keep on exploring your world.